So in this experiment, we are going to measure the resistivity of water, and by resistivity actually resistivity is the opposite of conductivity. So the idea is to measure that resistivity in order to be able to calculate what we call the formation factor, as you will find in your data sheet or in your SOP sheet. And the formation factor actually goes into Archie equation that we use to calculate the saturation in our formations. So that's why the resistance of brine or of your core is important. So the idea of this experiment is that we will have a core fully saturated with brine, and then we'll measure the resistivity across this core, and we'll have also this core partially saturated with brine. One time, each time we decrease the saturation of the brine inside the core by blowing air across it. So in order to do that, we have to follow our procedure. We have first we have 3 calibrations that we are going to go through. We have a calibration for fluid resistance. We have an RW measurement with brine using the dip cell, and we have a calibration for the core resistance measurements. And then the last step will be to do our measurement or resistant measurement for fully saturated cores, and we will repeat those steps for the partially saturated cores. So in order to start, first things first, we need to put this switch to RW cell. And then we will go back to the system and we will disconnect any BNC connectors. So we see these 2 BNC connectors, just rotate them until they no longer move, and then pull them. And then we will add what we call the jumper cable. So we'll connect it in its place. And then on the front of your instrument there is a button called 0 trim. So you press this button and hold until you see this SCE, and then you leave it, and then it tells you pass. After it tells you pass, you can remove the jumper cable, and now we have calibrated or finished the first calibration. Come back, you remove your jumper cable, same way. After that, you connect your original BNC connectors that are coming from your cell. This is your dip cell. So you pick back your BNC connectors and connect them again. Go back to the front of your cell. Make sure this is in the same position, or W cell. And then you take the dip cell out of the distilled water, and then you start shaking it to make sure there is no distilled water in there. And then if you are sure it doesn't have any distilled water, you can start dipping it in your brine that you use to saturate your sample, or any brine is fine. So you take it out, just shake it. And then maybe we can also, for accuracy, can just rinse it with brine. And then you can put it in your beaker of brine. You can use it. It's better, of course, if you use like fresh brine that you didn't touch, but this one should be fine. It needs to be at least 2 inches of brine in there. And try to hold it in upright position without falling to any sides. After that, you make sure that the frequency here is 10 kilohertz, as you can see here. And then you record the value of resistance that you can see on the screen. This is your resistance in ohm. And if you want to convert it to ohm meter, you need to subdivide this by the cell constant. Cell constant is actually written on the cell for you here. It's 1 per centimeter. So when you subdivide this by this, you get ohm meter. Just convert this to meter instead of centimeter. After that, you take the cell out, you rinse it thoroughly with distilled water, and then you put it back in the storage DI water. This one needs to be full, not half full like this, but for the sake of your knowledge. So you bring distilled water, you wash this thoroughly. And then you put it back in your DI water. And then hold it in place. So now we finished the second calibration. Third calibration is for this part of the system. They call it ambient electrical probers, and this is what we use to measure the resistance of our sample as well. So in order to do it, first you need to adjust the pressure here to 25 psi. So you rotate this big knob until you get to 25 psi. After that, if the copper piece is not placed in there, you just place it in. But now since it's already here, we can just continue. For these two switches, you need to make sure they are in the up position. And then you go back to your system here, convert this to core, and convert this one or this switch to 2-term. So both of them should be down. And then you come here and you come to the 2-term and bring it down, bring the switch down. When you do that, this part of the system will go down on top of your copper piece. After that, we will come here to our main instrument. You will see this button, we'll press and hold until it shows you the same thing that it showed in the past, busy SCT. So I press and hold, busy SCT, and then I release, and then it should tell me pass. If it tells me pass, then I can go ahead and bring this piece up again. So I'm going to bring it up. Now it's released. So now we remove the piece of copper and measure the. Okay, let's take it step by step. So we're going to remove this piece. And then press and hold the same button again, which is 0 turn, until also we have busy OCT. Once we have that, we release. If it tells me pass, then we finish the calibration. Now we go ahead and start measuring the resistivity of our sample. So we'll take our sample from the brine beaker that you see here, and we'll wipe it away with paper towel, just to make sure there's no excess brine around your sample, and then we'll put it in the place of the copper piece here. So in order to do that, cup and glove. Out. Try to dry any fluid on the outside of the core, so that you don't get an overestimated value or less estimated value, underestimated value of the resistance. Okay, now it should be good. So open here, put the core on that plate. Inside the opening, close the door. And then we'll bring this piece down so that it can measure the resistance across the core. So you get also to the two-term switch. Bring it down and make sure the frequency is 10 kilohertz, which there is no reason to change it. And then start reading the resistance value from here and record it in your table in the datasheet. So after that, initial measurement of saturated sample. So here is where you record your fully saturated measurement. And then you just take it up one more time. And then it goes up, you remove your core, put it back in brine. But for us, we are not gonna put it back in brine, just take this core and blow air at the core. So how would you know the saturation of the core? So there's two steps to do this. You need to measure the weight of the core fully saturated, and you need to measure the weight of the core after blowing air on it. When you have these two weights along with the dry weight of the core, you can calculate the current saturation in the core after blowing air on it. So make sure you always record those weights as you see here in the table. Like for the sample number 1, you need to record its weight, its saturation is 100%, its saturation is less than 100%, which is our current sample. We will measure the resistance, we record it, and then we take the sample out again, we blow air one more time, we weigh the sample, and we calculate the saturation, and we measure the resistance, and we do that 3 times, partially saturated. So, yeah, that should be it for the sample for this lab.